Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. Let's continue on the geometry treasure, which we are talking about the properties of the incenter and excenter, or incircle and excircle. So here is property 2. Let circle I be the incircle or excircle of triangle ABC and its tangent to side BC on point D. Let DP be a diameter of circle I. Let line AP intersect BC on G. Prove BG equals to CD. So for this problem, we know that we can start from the incircle, and let's draw the incircle first. This is our incircle, and right, so we have triangle ABC here. We have the incircle of the triangle ABC as circle I, and we know that the circle I is tangent to BC on point D. Let's call it E and F here. And we know that DP is a diameter right? DP is a diameter. This point is P. DP is a diameter of the circle I. And the line AP intersect BC on G. So line AP intersect BC on G. We want to prove that BG equals to CD. Okay, so for this problem, notice that we want to prove that BG equals to CD. And we need to think about what we have here. We only know that I is an incircle of the triangle ABC. And we know that DP is a diameter of the circle I. So we know that ID is perpendicular with BC. And the question is that how to use the condition that DP is a diameter, right? Generally, we can think about that DP is a diameter. We can find the property that if we mark this point as S, we connect the DS, and we know that the angle DSP equals to 90 degrees, which means the triangle GSD, triangle DSP, and the triangle GDP, they are all similar. But we start here because it's only about this triangle. There's nothing about the DC and the BG. Right? If we look at the DC and BG, then we can think about that we want to have some information about, because we want to prove that BG equals to DC, right? So we can think of, we want to have some information about BD and CG. So if we can prove that BD equals to CG, that's a method, right? And for BD and CG, it looks like we can have some information because G is the intersection point of AP and BC. That means AG is a common set of the triangle ABG and the triangle ACG. Right? So if we can find a way to relate the side CD, side BG into this AG, then maybe we can solve the problem. So here is the thing that we can find we can do a parallel line, right? Do B prime, C prime passing through point P and make B prime, C prime to be in parallel with BC. So this point is B prime, this point is C prime, right? What we got here, we know that B prime, C prime is in parallel with BC. And most importantly, we find that the circle I is the excircle of triangle A, B prime, C prime now. Right, that's critical. Because of this, then we know that B prime I and C prime I are angle bisector of angle BB prime C prime and angle CC prime B prime respectively. So we can connect to B prime I, we connect to C prime I. And remember that I is circle I is an incircle of the triangle ABC, so we can connect to BI, connect to CI. What we get here? We know that this is 90 degrees, this is 90 degrees, right? This is easy to prove because B prime, C prime is already in parallel with BC, and because circle I is the excircle of the triangle AB prime, C prime. So that means the B prime I and C prime I are the angle bisector of this angle and this angle, which means this one equals to this one. And this angle is half of it. And this angle is half of this one. That means these two, the sum of these two is 90 degrees, which means this is 90 degrees. So the triangle C prime IC is a right triangle, and the triangle B prime IB is a right triangle. What else we can get here is that because this is a right triangle, so we know that angle DIC plus angle PIC prime equals to 90 degrees. And we already know that this is a right angle, this is a right angle. So we can get that triangle C prime PI is similar to triangle IDC. And also we have triangle B prime PI is similar to triangle IDB. Right. Now, based on these, we can get C prime P to PI equals to ID to DC. Right, C prime P to PI equals to ID to DC. Also for here, we have B prime P to PI equals to ID to DB. Right, which means PI times ID equals to PI times ID equals to C prime P times DC equals to B prime P times DB. Right, we get this. That means we have the relationship between B prime P and C prime P. Right, so B prime P to C prime P equals to DC to DB. Right, it looks like obvious because we have here, wait a second. Yeah, equals to DC to DB, and also because B prime C prime is in parallel with BC, so B prime P to C prime P equals to BG to CG. Which means we got that DB to DC equals to CG to BG, right? So we can do +1 on both sides, which means we have, 1 second. We want to have DC here, right? Yeah, we +1 here, so this one becomes 2 DB plus DC, so that's BC to DC equals to this one CG plus BG, that's BC to BG. So we know that BG equals to DC. Right, that's for the case that circle I is incircle. And for the case that circle I is excircle, which means we're looking for the case for, now we just need to prove that it's similar for the case that B prime, C prime, right? For the triangle A, B prime, C prime, which means that in the triangle A, B prime, C prime, right? In triangle A, B prime, C prime, we have the, let me draw this figure. Maybe it's easier. Right, in the triangle AB prime, C prime. Now we have this tangent point as point D, right? And we want to find the diameter here, this point as P, and we connect AP. Meet B prime, C prime on a point, we call it G. Now we want to prove that B prime G equals to C prime G. So we can do this exactly same thing that do a parallel line here. That passing through point P and in parallel with B prime C prime, we call it BC. Right, and then we do the connection here. We do the connection here. And it's obvious that we can prove this triangle is similar to this triangle is similar to this triangle. Then we can use the same method to show that B prime D times BP equals to C prime D times CP. Right, and then we have this BP to PC equals to B prime G to GC prime, which we can find that B prime G equals to C prime D. It's a similar thing. Okay, so for this property, I think the key point is to think of how to use the diameter. If you can figure it out that we need a parallel line for that passing through the P, then it becomes easier. Okay, I hope you like this video. See you in next one. Thank you.